I see only a few people have joined yet, but let's get going. I know there's people writing exams, there's load shedding, all those kind of things happening at the moment. So hopefully people will afterwards be able to look at this recording again. Okay, so as people join, let's just quickly do the things that we'll look at today, and then we can start looking at the previous assignment 2 as well of last year to see if there's tips for you guys. Also, we will have a session, so I'll reschedule or repost this meeting for, let me quickly see, for Monday around 6 to 7 as well. Monday or Tuesday, so that you guys can have a try at the first attempt, and then we can have nearly a chat session on Monday or Tuesday, so that you can still do a second attempt before you need to submit. I think on the 30th, if that has not been extended because of all the other issues. Okay, so we'll basically go through the last pieces today, and then we will also have a check-in on Monday or Tuesday. So I will do another calendar check-in for then, so that you guys just have. So please, over the weekend, up until Monday, try at least once to do assignment 2. Then we can have a check-in, and then you can have another try at assignment 2 before the deadline. Okay, so just a recap on the most important parts of this study unit 5, which is a big component of assignment 2, which is also really a big component in your exam. So in session 1 of your exam, this study unit specifically will have about 3 or 4 questions. Okay, so we covered discrete, and if you have done any of on the assignment yet, you will see you get some on discrete. Then we've covered binomial. With binomial, we're going to use the tables, and then Poisson as well. And depending on what we are looking for in Poisson, also going to use the tables. Okay, so this one, and how I want to explain this as well is, let me, while you guys are on here, I just want to go back to my study guide, because specifically for this one, and I think somebody asked me this as well in the week, that what we are looking for. So, or for what table we are looking at. So let me just get the study guide open. And I think it was around page 120, or okay, here it is. Okay, so that is Poisson. Poisson tables is I like the most because that's straightforward. So let me get to a smaller one that is, otherwise I will copy. Okay, so let's do this. I just want to create.
Jean,
Yes.
can you hear me?
Yes, I can. Yes, I can.
A quick question, eh?
Yes.
The Poisson thing that you're talking about.
Yes.
I have a question. Right? As during the week, I was busy with the Poisson tables, and then in the study guide is where they give us 0.62, right, to check for to calculate the Poisson the probability
Yes.
for 0.62. So with the way of using the Poisson, if you go to 0.62, there's no 0.62, but there's 0.60. So now I was wondering if a question like that comes in an exam and then you have 0.60 and they give you a 0.62, do you have to calculate it manually or there's a way you can do it?
No, they will not.
Oh, okay. You asked me. No, Sam.
So no, in the exam, it will be that you can use the table. So there will not be in the exam anything that is weird, like a 0.55 or a 0.62 or anything like that. So please, in the exam, there won't be any weird stuff like that. If there is a 0.62, you use the 0.6, and that's it.
Okay.
What was that from a previous exam? That you got that?
I saw it from the study guide. Those questions from the study guide. There was a question that had 0.62 in it, and you had. If I go to the back of the book, it's I think question 3. Question 3 on page 82 of the study guide.
So okay, so and I think, Sam, that's also a good question to ask, because what the study guide does is it also wants you to, it's more about practice. So the study guide would nearly, if they give you 0.62, they would have wanted you to practice a bit with this formula.
Yes, that's basic because I only realized about the Poisson tables when I watched your classes, because when I was just doing it on my own, I was only using the formulas because I didn't know about the tables.
Yeah, so there will be a few questions in the study guide and in previous exams when it was still paper based, where they sometimes gave one of those weird formulas so that you actually needed to calculate it. But going forward, that was basically taken away. So the lecturer that did that is not at UNISA anymore, but he was still the writer of a previous study guide. So we are actually in the process this year to redo the study guide with the latest lecturer. So that, but yeah, so if there's weird things like that, it will only be in the study guide so that it nearly makes you practice the formula or to use the formula. But in the exam, please no, there won't be those weird things, because in the exam you don't have time to work this out in the exam. That's why you get the formula, the formula page, not the formula pages, the tables. Okay, so with this question, I thought what was good to look at. So suppose that 10% of butterflies have damaged, and let's have damaged wings. If a random sample of 10 butterflies is selected, what is the probability that more than 4 have damaged wings? So here you would see, and it's not the 10, but in this table, you will see that here's the 10. So at the bottom, and this is now strange that this doesn't do that. So let me get another table, because, or did I not copy that bottom part, or it wasn't there even? Okay, there wasn't even that bottom part, which is also weird. Okay, so let me just see. So, and that is maybe good that I copy both in on this. So that you can see what's happening. See, so this is how the table would have looked. So you will see that at the bottom here, there's not any of those percentages, but on the second table, there's that percentages. So how it works is that you start off here with a 0.01. It goes all the way up until that side to 0.5. And then on this side, it starts at 0.5 and it runs all the way up until this side to 1. Okay, so basically how these tables work is if you need to work with, let's say, n was equal to 8, x was equal to 6, pi was equal to 0.1. We would go to where 0.1 is. We would have worked with those numbers, and if I needed to get x equal to 6, I would have gotten it this way. Okay, so that's the more straightforward one. Now suddenly we get where n is equal to 8. Let's say x is still 6 that we need to find out, but we work with pi that is equal to 0.8. Now we sit at the top one, we're like, ooh, it ends there. Okay, but then we go to the bottom, we look at, okay, so let's just, that should have then been at a different place, but let's go down. There we see 0.8, and then whatever it is going to be. So that should have been 0.2, and 0.8 is going to be the same. Okay, so if this was just made bigger. So just remember that at the top, it is till 0.5. At the bottom, it is from 0.5 to 1. The other thing that you need to look at, and that I now made a mistake here, is when we look at the top part, we go from 0 to 7 and we go downwards. When we're at the bottom, you need to look at this side, the right side of the table, because here we go from 0 to 8 upwards. So if we needed to find x6, it would actually not have been that one. It would have been that one. So when we go up to where the x is 6. Okay, so, and this is only for the binomial. So only for the binomial it works like that. And the reason why it is like this is, remember, binomial, you only have two outcomes. So basically a yes and a no outcome. So that's why you always have a 50-50% chance of something happening. That's why at the top it goes to 50, and then from 50 to 1 to basically complete 100%. Okay, so I just added it here because what happens in some of the instances is that so there was actually not one in here that did it. So if you get something like that in the assignment, just remember what table you are referencing. Okay, so what I've done here is, because the n equal 10 table don't have anything at the top, I used, because that would be n equal 10, and that would be your 10%. That will be your 15% or 0.15. So let's keep it in that order of how you would get it, and the 0.2. So that would still be x0, x1, x2, and we will count till down where we need to be. Okay, so suppose 10%, we've got that, and we've got the n10, so let's just show it on the table. So that's why I've copied this part over. So there was your n, there was your 90, so you would see I've copied the 0.3487 and that into it, 0.3487 and the rest. So that is where I got the table. In your exam, and I think in the assignments as well, they will just ask for questions. So you need to go to the tables. They will not give you the table for Poisson and binomial in your question. So you just need to go to the table for that. Okay, so we've got it, random sample of 10 butterflies. What is the probability that more than 4 have damaged wings? Okay, so I will copy that piece of work also out to show what that means. So more than 4, so that was 0, 1, 2, 3, 4. So more than 4 is from 5 and up. So more than 4 does not include 4. So more than 4 means 5 and up. So for this one, what? It's their question, Ian.
No.
Okay, cool. Okay, so more than 4 is 5 and up. So it is basically 0.015 plus the 0.001. And if we add those together, we get 0.0016, which is option 3. So what you will see, what they also do a lot is, if you misread it and only look for 4, you look at what that 4 is, and there would have been an option for you. So what would now happen in the assignment, and I think there was a lot of questions about how do they give you 1 or 2 marks for things that you get wrong. So if you now set 0,0112 as the correct answer, you will probably get 1 point instead of 4 points if you. So that is nearly how they're looking at it now in the exam. Okay, so that is looking still at the binomial. We get the n, we get the percentage, and we work it out. I'm just thinking you always need, so you will always need to get basically these 3 in your binomial to do anything. So if you don't get this, it's you won't be able to do anything with a binomial. So what I normally do is in when I look at these questions is nearly to say, okay, let's look where the things are. So that is my pi, that is my n, and that is my x. And then I know I've ticked all 4, and then it becomes easier to go and look for it in the tables. Okay, let's go to another one. Again, using binomial. If n is 4, okay, so there's n4. We're looking at pi, that is 0,2. Okay, we've got it there. So we're gonna work in this. And again, that's why I liked it more when it was paper-based, so that you don't make mistakes. So even in your exam, if you have a few copies of, or for binomial, maybe just 1 copy, and you actually highlight on the paper or anything, even in your textbook or in your study guide, what you are looking at, so that one just not get confused with all the other numbers in here. So we're looking at 0.2, and you could have actually, let's do it even better, only looking at this area, because we look at 0.2 and we look at where n is 4. Okay, so where n is 4, 0.2, we now need to work out the probability that x is bigger than 2. X is smaller than 2, sorry. X smaller than 2. So we're not looking at 2 because it needs to be smaller than 2. So smaller than 2 excludes those 2. It is only 0 and 1. And see again, if you look at what they've done, your first option is actually x equal to 2. So just be always careful that one is in the exam specifically, because you rush for time, that one does not make that mistake. So basically the answer to this is 0,4096, and it is actually times 2, so it would have been 0,8192, which is option 5. Okay, so very easily one can make the mistake by looking at x2. You see that number, you pick it, it's the first one, you go on to the next question, but actually reading the question a bit wrong. Okay, so let's quickly see the next one. Okay, so we will have the next one on binomial as well. Yes, question.
Hello, Jean and everybody. I'm sorry. Can somebody assist me? My screen is blank today. I'm unable to see.
Hi, Zintle. Zintle, are you there?
Yes, Obakeng.
How did you join? I think if you join via the link that was shared on WhatsApp, it's pretty easy to get to where we're at.
Yes, I did use the WhatsApp link.
Is it? I'm sorry, I don't know. Because I also had a problem in the past where I joined via the app, Microsoft Teams on my laptop, and then it couldn't go through until I switched back and I followed the link that is on the WhatsApp. Then it took me to where I needed to be.
Okay, I'll try again. Thanks.
Okay, cool.
If that problem happens again, I'll also just unshare and reshare my screen as well. And it might be when that it comes through on your feed. So let me,
Okay.
before you go away, let's quickly do that. And then the rest of the guys can also just tell me if they can now see again. So is my shared screen back again? Okay, so it is. So Zindle, do you still have a problem of not seeing the screen?
I still have a problem.
Okay, so unfortunately then I think rejoin again and hopefully it will work.
Okay, I'll
Yeah,
do that. Thanks.
That's a weird one.
Okay, thank you.
Okay, so we still looking at binomial. Did anyone already try the assignment? So nobody have tried assignment 2 yet. Okay, so if you have tried, you can give me a bit of background how they did ask these questions, but otherwise we'll check in on Monday or Tuesday. Okay. So the next one on binomial. So according to a report from the Center for Study Health System Change, 20% of South Africans delay or go without medical care because of concerns about cost. Suppose 6 individuals are randomly selected. Okay, so let's hope she can see now. Can you see the screen now or not? Still not. So 6 individuals are randomly selected, so that's your N. And then they ask, what's the probability that more than 4? So again, we go to more than 4. So x is more than 4. Okay, so we're only working with N6, so what we're actually going to work out here is what's the probability x equal to 5 plus the probability of x equal to 6. Okay, so what I've copied in is, here's your n, so it goes all the way to this side to 0.2. So that is actually already, I see that part didn't come with. So we are looking at pi 0.2, n equal to 6. We're only looking at x, where x is 4 and 5, x 4 and 5. And we see that, again, that answer, if we add it together, will be 0,0016, which is option 4. So again, if you look at this, you said, oh, it's x4, there would have been an option for you. So just this, I think you would have now clearly seen out of these 3 questions nearly that they, for the number that they give you, there will always be that as an option, just to make life more confusing for you, because not to scare or not to anything like that, but for the guys that this is now the first time that we're doing stats, and that is why I nearly want you to do as many of the assignments attempts as you can, because at the moment you're getting assignments that is 12, 13 questions, and you're getting 3 hours for that. So in your exam, you're gonna get a session 1 that is 12 or 13 questions. Your time limit on that session is going to be 1 hour and 15 minutes. So assignments 1 and 2 is going to be your first session. It is, instead of 3 hours, it is going to be 1 hour and 15 minutes for 12 to 13 questions. So you are really going to be time pressured. Unfortunately, I've got nothing to, I've got no influence on that. So, but why the assignments is also important is they take that into account, the time that you spent on the assignments. So that last year and the previous year, there was lots of times when the lecture would have extended or done something that in the exam you get more time because of things happening. So nearly as you go through your assignments, know that your exam will be much shorter, but yeah, just make sure that you do every attempt possible so that you can really get into the practicing of it. Okay, so we've done now binomial. So let's go over to Poisson. The difference between binomial and Poisson, except for the tables, is you nearly get the same information, but with Poisson, there's always time involved. so you will get the same type of information. They will talk the same language sometimes, but the main thing that's different is there will be a timing involved. So per day, per minute, per week. So I think in the 4 questions or 5 questions, 4 questions that we will go through, I'll show you there's always a timing involved. With binomial, it was just you do 2 things. What's the probability of it happening? So every time it was about you do something and you check if it's happening. With Poisson, it is what's the probability it's happening within a specific time. So that is also nearly how to identify if they don't tell you it's a Poisson distribution. Look out for that per day or per week or per minute. Okay. Then for me, Poisson is, I always feel it's easier to do than your binomial because the tables are much easier. So if you look at your set of tables for Poisson distribution, you get the Poisson number nearly, or the sigma. They give it to you. They can use different words for that, so we'll just cover that. But then it is as easy as if I said 0.1, that one looks at set of outcomes, and then we work out something. Okay, so let's do it in this instance. So calculate the probability that 3. So this is also something that you guys need to check, which they do a lot in the stats exam as well, is when I look at the question, that was very easy for me to see because it's a number. Now you like, okay, I've got alpha 1, or I've got it as 1.8. Ooh, where is my x? Where is my x? Because I'm looking for a number. So just be very careful also in the exam that they like to put the numbers into words. So it is also just more difficult to find sometimes. Because for me, I like it when I see this. So I would see that, and then I know nearly I can work with those 2 numbers. So when it's not in numbers, just be very careful where it is and what it says. So calculate the probability that 3 bank robberies or robberies occur in a day, where the number of bank robberies that occur in a large Gauteng city is Poisson distributed. Okay, so there we know Poisson distributed. We know it's in a Poisson distribution. We could have seen it there in the day, and here they also tell us 1.8 per day. So again, you would need to go to your table that is on your study guide, or there will be a set of tables that the lecturer will distribute a week or 2 before the exam, so that you have that packed together. So where sigma is, or 1.8, we know we're looking at that 3 robberies will occur. 3 robberies, 0.1607, and that is your answer. What they could have now said is calculate the probability that more than 3 robberies occur, or less than 3, or so there can be, like in the binomial where they said more than, less than, it can happen in Poisson as well. And hopefully there will be one or two of those types in the rest of a question set. So binomial, a bit more difficult than Poisson. Poisson, I think it's a bit more straightforward, but Sam, again, I would not want to do it like that one question in the study guide where you need to suddenly work with a formula, because if I now need to work out, say, what was it, 1.8, this question on a calculator, just to do that, it will take you probably plus minus 2 minutes. And then you need to make sure that you put it in the right order. If your calculator needs brackets, that you do it correctly. So again, you can, but I would try to stay away. Yes, Sam.
So Jean, basically you're saying the formula part, part of this whole thing, we're not supposed to master that. We can just use the tables.
You can just use the tables.
So there's no question that will come that needs me to use the formula.
No. So you will see in your, I think in assignment 2. So what they've done in assignment, they've done it last year. So they will not ask you to work out anything, but they will ask something weird about, I think it was with binomial. So it was not, was it study unit 4 or 5 where the combination and permutation things are? I think that is in study unit 4. So it nearly looks like you're working with a binomial, but it is actually a formula for permutation and combination. But then again, there is, on most of your calculators, there's buttons to work out the combination and the permutation rules. So I'll just check for that one, because it looks very weird. And I also, when I saw last year's assignment, I'll just check if I have something on that somewhere. But please, the purpose of Stats 1610 is not for you to memorize formulas or use formulas in this sense. It's the formulas that you will need to use is when we start calculating a Z value and those kind of things, or confidence interval. It is definitely not to use this formula of binomial and to know it off by heart. And just that is how the subject has changed as well. A few years ago, it was actually part of the study that it was still closed book. You needed to remember your formulas. So luckily they moved away from that, because that was just rubbish, that you needed in a subject like this to nearly remember all your formulas, and it was still multiple choice. So that was terrible times. So this is at least a bit better at the moment. So please, no formulas for these two study units. Okay, so let's look at the next question. So again, here they talk Poisson distribution, But if I didn't tell us Poisson distribution, let's see what else they give us. Was used to model the number of faults in a gearbox. See, so if we just got this, if I said, okay, we used a distribution to model the number of faults in a gearbox of buses. This part, you can still think of it as binomial, because number of faults, so faults happen, faults does not happen. So just with that, and let's make it a different color, just with this part in light purple, we wouldn't have known if it was binomial or Poisson. So they add the Poisson, but if I did not add that, let's see what they tell us. Suppose the faults occur at an average of 2.5 per month. Okay, so there they add in the per month, so here we know it is Poisson. Okay, so the probability that at least, so now we need to, so we know that we're working with 2.5. The probability that at least 2 faults. So what does at least 2 means? So that is now open to the audience. What does at least 2 mean?
No less than.
Cool. Okay. No less than. So at least 2, so 2 and more. Happy with that? Okay, so and think of it, it's sometimes difficult to when we see it in stats terms what to do with it, because need to be honest, Afrikaans is my first language, English is not, and when I see words like this, I get also really confused with what it means. But if somebody tells you that I want to sell something for at least $100, I know that when I tell somebody that, they must not sell it for less than that. So I always try to, when I see these kind of words, I try to make it more practical for myself to remember. Because what the words we will get is at least, at most. I'll, in the next session, I'll look for it. There's a table in the study book that I'll copy out that gives you all of these words that they throw into the assignments and into the papers that we use. Okay, so now we've established that at least 2 means 2 or more. So now you've got the option. How would you, if I look at this and I look at, okay, so I need to add all of these numbers. Okay, so that will be a lot. But what I know is that in any probability, all of those probabilities need to add to 1. So instead of adding 0.2565, all of those together, I'm going to say, well, 1 minus these 2, because then I will get this set of answers. Instead of, you can still add all of that together if that is your preference. But for me, I'd rather just say 1 minus the other 2. So remember, in Poisson, in discrete, in binomial, when we get to normal distribution, all of the distributions, the probabilities would need to add to 1. So let's see 0,0821. Hey, quite interesting. That was one of our options. So you can even eliminate that. Plus 0,2052. So 0,873. So 1 minus that is equal to 0,7127. And again, not say anything sneaky, but just see how close that and that is to one another to make the mistake. Because you can quickly just look at it and flip. It's very close to make the mistake of selecting option 5, but your correct answer is option 1. So again, in the exam, just be so careful how close that and option 5 is together. Yes, Sam.
Okay, looking at the same table, right?
Yes.
We know that the probability is up to 1, right?
Yeah.
But then if you look at this 2.5, and if I had worked it out the way where you put the question mark.
Yes.
Can you see
Yes.
the stuff that you put the question mark on? If I had to add those things, I was gonna get 0.7126, which is not on the options.
Okay.
So
See,
basically,
so that is, then you go for the closest one, because what would have happened, and that is unfortunate with this now, is that somewhere here there probably was a rounding off that it happened. So this was probably 0,4 and there was something else, but that is unfortunate. That, so again, in the exam they would have made now sure that that will not happen. And if that happens in the exam, you WhatsApp me directly. So our chat will be off during the exam, but I am available that day during the exam, and the lecturer is also basically in constant communication with the tutors that day. So if anything like that happens in your exam, you WhatsApp and you tell me. The same if you've got connection issues, or if there's any of those weird things that you guys are now struggling with during your June exams, you take pictures of you can't get in or this is happening, send it to me, I'll send it to the lecturer, and yeah, so I think this, I haven't worked in another department nearly where I ever had access directly with as a tutor with a lecturer via a WhatsApp group that I can send a message and he replies within 10-15 minutes. And in the exam, he's watching that WhatsApp's coming through. So for this case, when you do it and you're very close to it, pick that answer that is closest, But if something like that happens in the exam, please use the WhatsApp channel and tell me, John, I've done this, I'm off by 0, and we'll sort that out. Or you can afterwards even say to me, just question 5 was this. I know what they are going to tell you during the exam is not to take pictures of the questions, but if you feel there's something wrong with the question, take a picture of it, send it to me. Because what I will tell the lecturer is I'm seeing that students are complaining about question 4. So that he, even before it is going into systems and markings, that he can look at it. Okay, so that is what, in your assignment, you do the same. If go for one that is closest, but also tell me if you're going through assignment 2 now, because that's what I did with assignment 1, was on that last 2 questions, where I also thought we were working out Q1 and Q3, and we were actually working out other stuff, where I asked the lecturer, but I think here's a mistake because all the students are complaining. And he said to me, but we're looking at the wrong equation. So please, again, also in the assignments, if you pick up something, send me a WhatsApp after you've done now your first assignment attempt, and say, your question 4 seems weird. Is it right what they're asking? And I will communicate with lecturer. Okay, so let's look at the next one again. They tell us Poisson. We need to see, okay, so this is a nice question to nearly see if we know all the things about Poisson. Assume X, we don't get a X, so we don't know, so we're going to get questions around it, which is cool, so that we can nearly see what to work out. At least we get the lambda. So the lambda is 6.0, and then which one is incorrect? Okay, so the first one that I always look at, and it is also on the study guide, or the page that I've made a summary of, your lambda is equal to your mean is equal to your variance. So that is equal to your mean equal to your variance. Okay, so that for me is nearly the first prize, to look at those options in your set. If one of those is wrong, then you don't need to work out all the rest. So in the exam, that is where I would nearly, the same with a binomial. Where did we do? So the same with a binomial, if I will first work out the expected value and the variance, because with binomial it is easy, with Poisson it is easy. So my lambda is 6, so my mean needs to be 6, and my variance needs to be 6. Okay, so here they talk variance 2.45, wrong, because it needs to be 6. So if this was an exam question, this is how you make up some time for the rest of the paper. Easy one, 2.5 is wrong. It should be 6. You don't actually need to work out any of the others. Go to the next question. But if that was 6, we need to work out the rest. So let's quickly work out the rest. So x equal to 0. Okay, so here we only need to see where x is equal to 0. So only x equal to 0, which is 0,0025. So that is correct. So let's see x smaller than 3. So not including 3, smaller than 3. So it is 2. So it is those 3. So at this moment, I will still add those 3 together because there's just too much left on the other side. If they told me about 7 or 8, then it becomes a different situation. But so I would say smaller than 3. So I would add the probability where x is 0, 1, and 2. So when we do that, it is 0,0025. Let me just 0.0025 plus 0.0149 plus 0.0446, and that we get 0,062. So if we add those 3, we get that, so that is correct. Okay, now here it becomes interesting. Bigger than 5. Bigger than 5 is 6 and more. Okay, so all of them. So we can add all of them, or we can say 1 minus this group. And those two will be equal. Okay, so let's add all of this. Somebody else can add all of that if they want to. So basically 0,0025 plus the next one plus the next one plus 0,0892 plus 0,1339 plus 0,1606. Okay, so for that I get 0,4457. So remember, I need to subtract 0,4457. So if I do that, this part will add to 0,5543, which is that. Okay, so you guys can test this one out as well to see if you add all of that together, what do you get? But for me, I rather add 6 things together than 11 things together. Again, just looking at the time in the exam that you get and things like that, much easier for me to, on time-wise, to do the opposite. But again, please do what you most comfortable with. Both is correct. Both will get you the same answer. The one might save you a bit more of time, but please do what is easiest for you to do in the exam and in the assignments. Okay, so let's look at the last one that we just get this also sorted out. Okay, so x smaller than 5. So x smaller than 5 is from 4. X bigger than 2 is from 3. So I'm looking at between 2 and 5, which is 3 and 4. So it is 0,0892 plus 0,1339. See, and now, Sam, again, I think if we look at that, it is going to be not exactly the same. Boy, okay, I'm getting totally a different answer now. Let me just see if zero comma 1339 plus 0,0892. Okay, so here is a mistake in this question. Okay, so here is definitely a mistake. So what I'm wondering, and let's just, no, I actually don't know what, because I'm now adding. Okay, so they nearly wanted it to be, they wanted it something like this nearly. Okay, so this is actually also wrong. So nearly, and I think that is also point taken. If this happens in the exam, you let me know immediately. If you came across to even now in the assignments, I think it's good that one gets into that situation, or not get into that situation, but in that practice of, if you think there's something wrong in the question, if you see something like this, you take a, did I make something wrong, or Milano on that did? Oh, what did I? Okay, that is quite interesting. .1339. So is there something in the table that is wrong? You can quickly unmute and say, where did I make the mistake?
Hello,
Yes.
Yummy. You added 0.039 and not 0.339. 1339.
Oh. Okay, so let's quickly. Yes.
Even if you edit with the 0.1399, because when I did it, I also got my final answer was 0.2677, which is not there on the option.
Okay.
So this question is 2 answers that are wrong.
Okay, so even if it's done the other way, it's still wrong. Okay.
Yeah, you get 0.2677.
Okay, cool. Okay, see, so please, if that happens in the assignment, let me know. If that happens in the exam, definitely let me know. What normally happens in the exam, if something like this happens, all you will get your 4 marks, or they will drop the question. So it's not that will penalize you. They will maybe drop the question, or you will get your 4 marks. So just, but please, if you see something like this in the assignment or in the exam, please ask. Okay, cool. So let's do the last one. And I think why did I have 2 here? It might just be that the one was so small. I don't know if there's difference in numbers. It might just have been on the size of the numbers, but we can quickly check when we do the question. Okay, so here they don't in that tell you it's Poisson. Okay, so here in the options they ask you if it is. So let's see what they tell us. A cashier at the cafeteria or Castor's cafeteria can on total an average of 1.2 trays per minute. Okay, so that per minute with that tells us it is Poisson. Okay, so looking for the incorrect one, so let's just check. The problem follows a Poisson distribution, so that is correct. Then what it does say, what do we look at? So we look at the mean is equal to the variance, which is equal to the lambda, which is 1.2. The variance of this problem is 1.2 trays per minute, which is correct. So that was the second part. So that is part of the definition. Sorted. Okay, so let's look at the third question. The probability that the cashier would total exactly 0 trays per minute. Okay, exactly 0. So what's the probability that X is exactly 0? Okay, so what I like about this question now nearly is where in the previous one we had it in symbols and things. Now one has it all in words. Okay, so that you can also see the difference in what we are doing between words and the symbols. So X equal to 0, exactly 0. We work with 1.12. So there we have it as 0.3012. Okay, there it was as well. So I still don't know why I've done two tables. So we'll find out if there's any other things that was different. Okay, so option 3 is correct. Okay, let's look at question 4. The probability that the cashier would total at least 4 trays. Probability that the cashier will at least 4. So 4 is the minimum. Okay, so we can write it in 2 forms. We can write it as at least 4, so 4 and more. So 4 or more, or we can write it as it needs to be bigger than 3. Okay, so that part we could have written as 2 different options nearly. So bigger or equal to 4 or just bigger than free. So in this instance now, I would look at this and say, okay, bigger than free. So I would rather go smaller than free. Then I need to add those 4 instead of adding 1, 2, 3, 4, 5, 6. Okay, but here is some that is negative or 0. So in this instance, to do it as 1 minus that part, the 1 minus that part, or just to say the sum of this, not going to be really anything different. So whichever one you most comfortable with, you do. So in this instance, I'm actually going to go with option 2 and just add things together. So 0,026 plus 0.0062 plus 0,0012 plus 0,0002, which in the end now gives me something different. Okay, so it gives me 0,0336. Okay, so let's see. Okay, so it's exactly the same if I used that. Okay, so if I say one minus the other, I just now want to check. Okay, so let's say 0,3012 plus 0,3614 plus 0,2169 plus 0,0867. So if I add all of that together, I get 0,9662. If I say 1 minus that, I actually do get 0,0338. So again, oh, so it gives me that. So again, this is where I think the issue of the rounding off comes in, because that should in actual fact be exactly the same, which now makes it difficult, because in the exam I would have nearly wanted to say that is also wrong if I did it the second option. So again, if you get in the assignments or something like that, just make a note, go for the one that's the closest to what you get if it is not spot on the same, but nearly, and take that picture of that question and send it to me. It's not that you're sending it to your friends or anything like that, that's also doing it to get marks, because it's, again, for me in this instance, this would create doubt. So this would now create doubt with yourself as well. Well, is it right? Is it not right? What mistake did I make? And it shouldn't be like that. So both options must give you the same answer. So obviously there's some rounding off in the table that happens, but it should not be like that. Okay, so let's just look at the last one. The probability that the cashier would total at most free trays. So now it is nearly the opposite. So probability at most, so not more than free. So smaller or equal to 3, or you can say probability that x is smaller than 4. Okay, so probability x smaller than 4, and that is actually what we have worked out in this instance. So probability x smaller than 4, it is exactly what we've done here, which should have been 0.99 or 9662. Okay, so that is why that one is wrong. Okay, so x smaller or equal to 3 or x smaller than 4 would have given us the same thing to work out, and that would have been the 0.9662 that we actually used in the first one. Yeah, so unfortunately, again, that rounding off, it should not happen. So if it happens in your assignment or in the exam, please, that is where you let me know. Okay, so that is study unit 5 that we've done with. So I would recommend you guys over the weekend, and that is if I don't even know if my UNISA is actually back online. That is also another issue at the moment, that the whole system was off yesterday. So if it is at some point online, go and try your first attempt on assignment 2 if you haven't done it yet. We've now gone through everything, but I will set up time for us, let's say on Tuesday, so that at least you get today, tomorrow, and Monday between load shedding and all of those things, just to try a first attempt, and then we can do a check-in on Tuesday, so that you still can do a second attempt before you need to the closing date on the 30th for assignment 2. I don't know, but I won't be surprised with all of this things happening at the moment that you might get a extension on assignment 2, but I don't know. So let's not hope for it. Let's just rather work towards the timeline of the 30th, and if anything happens, I will let you know via what the lecturers say. Any questions, guys?
No, my UNISA is actually back on now, but I'm gonna try and do it on Monday, because I'm gonna take because
Yes.
I can
Cool.
see it's back online now.
Okay, so thank goodness for that. So yeah, so it I don't know what to say about that, so let's rather not say anything. But yeah, so thank goodness it is back online. But try your assignment somewhere before Tuesday. So I will schedule us sometime on Tuesday. I'll just need to check what is the load shedding schedule on my side as well. But I think it will be fine around 6 o'clock. But even I will be able to do at least an hour on the stuff that I have in place here at home. So I will see you guys on Tuesday around 6 p.m. for a late session, just to make sure that you're ready to hand in assignment 2. Okay, anything else, anybody? Otherwise, have a good Saturday and good luck with all the exams if you're still writing.
Okay, thank you very much.
Cool.
Goodbye.